Hello. So, decided to make one more video with Philips Sonicare toothbrush repair video, and to make it as a ultimate repair video, or let's say everything in one place, and based on the experience that I had or made with all these repairs, to make it as short and as informative as possible. So. First of all, I will link here, or not link, but place. I thought that I will make one more time opening and an explanation of the opening of the toothbrush, and then I will start with the mechanical repairs. That's the most easiest and common repairs. And then we will jump to a few electronic repairs, and in the end I will place it, or in the beginning, it will depend. I will place my own how do you call diagnostic methods, or how to diagnose what kind of defect do you have. So let's start with an opening. To open up, you need the toothbrush. Yeah, this one is working, but nevertheless, somehow a lot of defect toothbrushes went up in price. I'm not sure if it's part of my repair videos, but somehow they are much more expensive to acquire. So I will open up one of my repaired ones. So what you need to do is place something, paper or tape around it. Take pliers and squeeze it a little bit, so there would appear a little gap on side. So here is a gap I'm looking for. I'm placing a spacer inside it, and then rotate it a little bit to the side and pop the sides. So, and then this side already pops out. Then again, go around a little bit, look for a gap, insert the spacer, go around and press from the, it jumped out. Or yeah, one other method is just try to press around in all kind of directions, and if you don't have a lot of debris, toothpaste and so on, it could pop out. Okay, nice. This is done. Let's place it so I will not forget it. Okay, and now for another part that you ask a lot is how to take it out. There's a separate video for this, but let's try to make one more, maybe with better lighting. So then what you need to do is take the toothbrush, place with the metal tip onto the solid table, firmly press it down, and then inside you are looking for tabs, plastic tabs. I will take it out and show it one more time here. It's that easy to take it out. What you're looking in there is for this tab. You insert it there and press on it, so this square fastening point would go out from its place in here. That's it. You take it out, and then you can inspect it and see what is wrong with it. I will make a better picture with my microscope and place it here in video, so you can see the elements and have a better look. So as how this toothbrush works is you press the button, signal goes into the controller. Controller sends the fast signals to these double MOSFETs. So this one MOSFET is two separate channels. This one MOSFET two separate channels, and with that it acts as a very fast switch to turn on polarity at the electromagnets, magnet coils, change the polarity, and turn it on so that the magnet would change its positions as fast as possible, and it's fast. Yeah. Okay. Yeah. Then few other points that are interesting is this fuse, battery contacts, and this jumper. Yes, sometimes you can make a hard reset by removing. If you don't want to remove the battery, it's two solder points, and then it's a little difficult to take out the battery. If you desolder this point and you may have these, there are 2 points that are not touching itself, then you will basically remove the power from the whole board. So it's quite, if you're first time you're working on it and you have to touch some parts of the board with metal shaft and so, or a pin set or something, it's better to remove this point, so then your board will not be live from the battery. Yeah, then we have the coil, charging coil, and some part that is responsible for the charging, or this is the part that I'm not that familiar, but I'm assuming in this, and maybe in future there will be one more video about this. And yeah, then one more important thing is this rubber seal. This is the most problematic point from my experience. Okay, but let's get back to the let's get back to the plan. Okay, so now I would like to talk about mechanical damages. In principle, what you have in this toothbrush is okay, maybe I will take another part. Let's talk only about the mechanical part. So you have, it could be, from my experience, maybe 5 or so mechanical difficulties with this toothbrush. If here you don't have a gap, then it means that the toothbrush was dropped, or yeah, maybe the screws gave up, but in principle, if you don't have a gap, it vibrates very with slow, how is it called, without noise, or the noise is another way around, is very strong noise, especially if you press this and the space is very small, then the magnet is touching the electromagnet, and it's quite vibrations disappear or are very weak, but there's much more noise. So if you want to repair this, you have to unscrew this, as in, I will link one of my most popular videos how to repair this defect. You unscrew these screws, insert something here like a screwdriver, push it out, insert a small plastic card to get a from 1 to 2 millimeters gap. I'm always telling that as little as possible is better, but yeah, you can try 2 millimeters or something like that, and it should be good. Then you take the screw, put some Loctite on it or some other screw fastening liquid, and screw it in. The same for the other screw. Then you take out the plastic card. Voila, that's finished. If you take it out and this pin wobbles strongly, or you can take it out, or let's say if you just here push, get in some sharp thing here, and then take out this plastic. from the other side as well, and then this drops out. It's because it's broken. Here there be a lot more metal, and if it's broken, you have to replace this. Not a big deal, 5-10 euros, and then it should be easy to replace. You just unscrew the screw, get a new head, and screw the screw back in. If it just wobbles and you see that this part is okay, it could be that this screw is very loose, and that's why it wobbles and you don't have any vibrations. For this repair, you just unscrew the screw, put some Loctite on the screw, screw it back in, and it should be good. Then what I experienced, there are two quite difficult well, I didn't experience them a lot, but there are I had some comments about similar damages. Let's say you see there is no gap between magnet and electromagnet. You perform this procedure that I linked in the video before, and when you take out the plastic part, the magnet jumps back straight to the electromagnet. What this means is that you have here, you have this shaft and this magnet, and what you have is broken shaft. So there's no easy fix, no nothing. Yeah, you could well, let's not even think about it. It's not repairable. You need to replace the complete head, and that's it. Another defect what I have here in hand is when the magnet moved a little bit to the side. Not sure why it happens, but as you see in here, it happens. If you put it back in place, it's kind of almost stays in place, but you just push it a little bit and it gets back into this slightly sideways. And yeah, when you turn it on, it makes a lot of vibrations because this part touches the metal frame. And as theoretically it's possible to repair it. You should cut the frame, and then you could get access to it. And my assumption is that maybe this screw got loose, or maybe at this point it got loose, and that's why it's on the side. But yeah, it's not easy, and afterwards to somehow fasten this frame, yeah, again, it's stainless steel, it's difficult to cut, so I would say it's much more easier to replace complete electromagnet part, and yeah, live easier life. Okay, and one more, I would say a mechanical part is if you get or mechanical defect is if you get toothpaste into this through this gap inside, it gets inside even more and more and more. And what it does is it yeah, you get sometimes toothbrush turns on by itself and so on, and it's difficult to push sometimes, but if the upper shaft is okay, seal is okay, if it's really not contaminated and doesn't have any holes in it or black spots, you could just take your whole toothbrush underwater, press hold it a little bit underwater, press a few times this button, and you will see this toothpaste coming out, and it should be again freely moving. Okay, second part is electronical damages, or damages that were found on electronical side. This usually happens only, okay, not only, but 95% if this seal gets contaminated, gets toothpaste on here, it hardens, gets a micro tear into the seal, water gets in, contaminates the whole PCB, and yeah, all the nasty stuff happens. What I usually do when I open it up and I see some of the water damage, I usually remove this point just to be safe. Then I check voltage. If it's low, yeah, again I remove. Okay, I desolder these two points, then remove the electromagnet part like this. You just take it on the electromagnet side and on the battery and electronics part, and just push, or how do you say it? Yeah, push into the separate sides, and you are good to go. And in here you have two clamps that are usually holding it in place. Even if they break, it's not a big deal. You can afterwards assemble it, and it's anyway held by this spring inside and these clamps that hold it in frame. So these are not that important. Okay, then back to the business. Desolder these 2 points. Then you have a more easily, you can work easily with it. Then I like to desolder the battery, and then all you have to do is desolder these 2 points that are this is the coil pins going through the frame and solder to the PCB. When you desolder these 2 points, you can easily take it out. These 2 plastic pins hold it somehow in place, but you can just squeeze it with pliers or just cut it out, and they are not that really important. A little bit for this part to be in place, but yeah, just squeeze it with pliers and then you can take off the board. Very important is to have a clean desoldering of these 2 points and battery. That's it. Then what you will have, you will have PCB on your hands. Let's take this one. And you should always inspect backside, because usually backside has even more damage than front. Let's take one example. Let's say here. You see the front side is not that contaminated, but if I turn it around, nice. And what happens is water stays inside. It cannot evaporate that easily. It penetrates these through hole how do you call it? Through hole holes, and it stays there inside and corrodes the metal and gets under the PCB protective coating, and yeah, that's all this damage. Okay, but for electronical, what I usually like to do is I check the voltage, check if this fuse is okay. You just take multimeter, put it into the continuity and check if this fuse is okay. Then what else is this button gets contaminated inside, and this trace usually corrodes away. So this button has 2 defects, not only this trace but the button itself. To check the button, put it in continuity, put the multimeter continuity, touch these 2. I'll link one of the older videos that I firstly found this defect. get your probes onto these two points and push the button. If it rings, wonderful. You can put your multimeter into the ohm resistance meter, and when you press the button, the resistance should be only a few ohms. If it's at 30 ohms, it would be quite a good idea to take it apart and or exchange the button, or take it apart and clean it, because inside, what you have inside is just 2 points, and on that points you have a metal plate, and when you press the metal plate, it makes contact. When the water with toothpaste and everything gets inside, it contaminates these contacts, and even if you press the button, you don't have a good contact. Okay, so we have fuse, battery, and button. From here it gets difficult, or not that difficult. I already explained it in other video, but I will in this video I will film how I'm repairing the traces, because then this next point is the traces that are going from let's say button itself to the microcontroller. And to check this, you have to put your multimeter into continuity mode, and what you want to do is check. Okay, I will try to have a closer look into this. Okay, so what you want to check is this test point, and it has to have yes, I'm in continuity mode, and it should have continuity to this point, because next to the R1, because there is no test beep, it means that this line is broken. Next point where you need to check the lines is the signal going from the microcontroller to the MOSFETs. In this case, we have continuity. You need to check the. I will link the other video where I explained it quite truly, the points where it needs to be. Here is okay, and this one is not okay, and this one is not okay. This point goes through this point and goes to the second leg. Okay, so we have 2 traces that are broken and 1 trace from the button, and additionally we have a quite contaminated button. I will take it off and show it to you, because I'm reading 300-500 ohms on these 2 legs. Okay, and yeah, one more last thing that we have is burned MOSFET. Here is one toothbrush that I left as an example, and we have this behavior. Okay, sorry, no, this one goes good. This one is from I think Sonicare Kids toothbrush, and if you press the button, there's 0 vibrations, strange sound, but if we look, we see that we have a gap and everything should be okay. So how can we tell? We have the tester in the same continuity mode, and let's check the MOSFETs. In here I place one of the probes on the both two middle legs, and then press the outer leg. Check it with the outer leg. The same middle legs, outer leg, nothing. Middle legs, outer leg, nothing. Middle leg, outer leg, nothing. On this one, however, on the middle legs to the outside, we have a short. Here, not really. Here we have a short. Here it's nothing. But again, this MOSFET is bad, and that's why there is no vibrations, because it actually activates only one of the coils. Yeah, we need to replace this MOSFET, and this toothbrush should be okay. So here I want to show you how I repair the traces on PCB, and yeah, it's nothing special, but you do need a microscope or a good magnification loupe or something like this, as the traces are very small, and you will need a small wire that would fit through holes. And yeah, in principle it's quite simple procedure. You just remove the protective covering from a trace to get to the copper trace itself, and just resolder it and recover the trace that corroded away with the wire. So as you can see, first I'm usually connecting the wire to the test point, and afterwards I try to make a shape that would stay in the place where I need to solder. Yeah, you can always use flux. A lot of flux usually helps. I do this on the last wire, but yeah, it's possible to do without flux too, as it's only two wires that needs to be connected. Yeah, just remember to keep your tip clean, and if you have some flux, just use flux, and it will be much easier and faster. If you don't have a good magnification, then maybe it will be a good idea to, or let's say you should have at least good magnification to remove the protective covering only from the trace itself, so that way it will be easier to solder. Because if you will add solder to the covering area, it could be I'm not sure, but I think it's ground area. So if you will cover it with solder, you could short out the PCB. But in this case, if you just remove the covering only from the trace itself, it's quite easy to resolder it. And yeah, that's about it for this. In here I'm recovering the trace for one of the MOSFETs that corroded away, and yeah, you can just enjoy the work. It's 3 times the fast forward, and I'll try to find a good music or some kind of music just to cover the silence. So after repairing the traces, I'm checking the continuity. Here it was okay, and in here I'm checking the continuity, and it's not happening. So here in the middle we have another broken trace that needs to be resoldered, and then it will be all good. And as for the button, as I said previously, there are two options. You can replace the button itself, or try to clean it. For cleaning it, as I said, it's good magnification is needed. So in this case with microscope it's possible and quite easy to do. You just lift up one of the casing legs and everything comes apart. Then you need to depending on the contamination, you need to either scrap it off or just use some isopropyl alcohol, and when you clean it you can reassemble it. Assembly is usually the more difficult part, but you will see in this video in principle you need to only work on one leg, and afterwards just prime it off and try to slowly bend it in back in its place as you will see in this video. So yeah, nothing too special, but it's first time it's quite difficult to do. So just take a look, and if it's your case you can try to clean it, but maybe resoldering is a little bit easier. And as I promised, here's my procedure or how I'm checking the toothbrushes. So if I get a toothbrush, I first of all check if it's turns on. You just press the button on the toothbrush itself. You press the button. If there are vibrations, if it's turns on, wonderful. You have only mechanical issues, and that's the easier part of a fix. So if it turns on and you have weak vibrations or strange sound and no vibrations, then yeah, you can jump back to the beginning of the video, and it's the electromagnet or yeah, it's the electromagnet. Magnet stuck to the electromagnet. If you have the shaft and it's moving, yeah, then it's either a screw or the shaft itself is broken. Then if it's hard to press, you need to wash it out, the toothpaste, and yeah, check all the seals. Then when you open it up, you just inspect the gap between the magnet and electromagnet. Shaft, is it the gap, the shaft, is it okay? And that's all with the mechanical. If as I told, you have some problems with the magnet or so, it's probably unfixable. Okay, then with the multimeter, if I have electronical damage on the water damage on the board, I take it off completely, because a lot of damage is under the board. Then clean everything with isopropyl alcohol, and then you inspect it with multimeter. You check the fuse, the battery, button in continuity mode, and the button itself, and PCB traces, and of course PCB traces to the MOSFETs and MOSFETs themselves. Yeah, that's probably it. In future maybe I will get to the charging problems, because I have a few boards that are working but doesn't charge. So this will be in the future, and yeah, never play around with battery connected and shorting out some of the pins. You could fry your microcontroller. Yeah, that's short for how I test it, and yeah, that's it for this part.